Wait, sir, just to confirm, alpha particles are protons,
Uh,
gamma particle, no, sorry, alpha particles are
Helium. It
protons and
refers
the
to the
particles
helium
are
part.
electrons.
Yes.
What are gamma rays?
Those are just radiations, just
Okay,
form of energy or form of wave.
all right.
Okay, so today we are going to start with the concept of half-life. And by the name half-life, you can easily identify that what is the meaning of this concept half-life. So basically, the definition. So the definition for half-life is time taken for a radioactive sample to decrease its radioactive nuclei to half of the initial value. So let's suppose if you are taking total mass of 100 grams, let's suppose, right? So by the definition of the half-life, we are actually talking about if you just decrease that mass to half of the original mass, that is 50 grams. So that is the concept of the half-life, right? And we are talking about radioactive or the radiations. So basically, in radiations, when the elements are emitting radiation continuously, so definitely their mass will also starts to decrease time by time. Okay. So the time required by each element to decrease their mass to half of its original value. So that time is known as, or that concept is known as the concept of half-life, right? Any confusion?
Wait, sir, can you repeat? Sorry, my mic cut out.
So basically, let's suppose, according to the definition, if you just consider a sample, any random sample, and that random sample has some atoms, number of atoms or elements, you can say that. So let's suppose we are having 100 gram mass of any element, and let's suppose after some time, the mass decreases to its half of the original value. So the time taken by that element to just emit all the radiation and decrease the mass by half of its original value. So that time is known as the half-life. Let's suppose this element take 1 year to emit radiation and decrease the mass to its original value by the half. And in the second concept, if you further wait for 1 year, so what will be the mass after 1 year?
25.
25. Okay, so this is a very simple basic concept of half-life. Because you know that in the concept of radiation, the elements are continuously emitting radiations. So after some time, definitely their mass their structure is going to be decayed, the quantity is going to be decreased. So the time taken by the body or any element to decrease the mass or decrease the radiation rate to half of its original value. So that time period is known as the half-life. Okay.
Sir, just a quick question.
Hmm.
How many topics do we have in total
In this chapter or in whole syllabus?
in the whole syllabus?
Basically, there are total 6 sections, right? And in that 6 sections, there are around, if we just consider the chapters, so 20 to 24 chapters. Because some chapters are very like small, only 3 or 4 topics in that, so we combine that chapter with another one. Okay. Basically, in journal physics, we completed the section of journal physics. There are 8 chapters in that. In thermal, there are 3 chapters, and we now started the radioactive nuclear physics. In this, we are having 2 chapters. Now, electricity consists of like 6 to 8 chapters more. Waves contains 4 chapters and 2 chapters from space physics. Okay. So don't worry about the chapters, just focus on the section because counting the chapter is like a difficult concept. You can easily identify by the number of sections, that how many sections are there and how many sections we just completed.
Okay, thank you, sir.
So the first definition is the time taken for a radioactive sample to decrease its radioactive nuclei to half of the initial value. And you can also write the definition for the half-life, that time taken for the radioactive sample to decrease its activity to half of its initial value. So both definitions are for the half-life. You may choose any definition to write in the definition of the half-life. And now we are having an important term over here that is known as activity. So the meaning of activity is, now we are talking about 2 different concepts. The first one is the emission of radiations from the nuclei. And the second is to compare that rate of emission or compare that emission with the time. Okay, so in short, we are talking about the rate of emission because rate itself explains the idea of the time period with the activity or with the whole process that is going on in the radioactive emission. So basically, the meaning of activity is rate of radioactive emission from the sample, or you can also write down the concept of activity like this, that number of radioactive radiations emitted per unit time. Okay. This concept is very simple, just like the concept of velocity and acceleration. We used to write rate of change of velocity, rate of change of distance. So same rate of radioactive emission from the sample is known as the activity, right? And let's suppose if we consider the graphical representation. So for the graphical representation, if we want to draw a graph between two quantities, let's suppose on y-axis and on x-axis, the quantity we used on x-axis is the quantity of time.
Time, yeah.
Yes, because time is independent quantity, so always plot time on x-axis. And on y-axis, we have to note down the number, right? The number of nuclei. Okay. So basically, let's suppose if we start from 100 gram, let's suppose. So basically, if we started from the 100 grams, so your graph must be start from the peak point, because we are going to decrease the mass or decrease the uh, mass of the nuclei or radioactive nuclei from the maximum to minimum one. So graph will start from the maximum point. So let's suppose if we consider the maximum point. So let's suppose we started from this point and this is your initial number of nuclei. Okay. So after some time, let's suppose we started from zero, and we know that element have half-life of 1 year, 2 year, 3 year, or whatever the time period for that. So let's suppose initially we take the value 100, and this will be the half-life with 50, half of the initial value, then 1/4, and then so on. You just decrease the number by half every time. Same goes on the x-axis. The first half-life, the second half-life, the third half-life, and so on, right? So your graph will starts to move in a curved line like this, okay? And you can easily mark their points with the reference, because for now we are just marking the representation of the graph with x-axis and y-axis when we try to solve the questions of this topic. So then you will get proper values according to the numbers and the time duration. Okay. And let's suppose if you consider a question of the half-life, Okay, if you consider question number 18. So in question number 18, a figure shows a radiation detector placed on a laboratory bench, right? And you can see the diagram shows you that 31 counts per minute is the value that is a detector counting from the radioactive source, right? So normally we use detectors of radioactive elements. So they just count the number of radiations coming out per second or per minute. So in this device, you can see there are counts per minute. So they just count the number of radiation or the number of elements coming towards the detector per minute. So the detector is switched on and 6 readings of the count rate are recorded. And the table in figure 18.2 shows the reading obtained. So you can see in the first minute or the first reading will be 31. After that, the next reading is 36, then 29, then 32, 31, 33. So this is the observation of the detector. So using all the readings obtained, determine an average value for the background count rate. So basically there is another concept of background radiation. So what is the concept of background radiation? Let's suppose we are using radioactive sample, right? So when you are using any radioactive sample, so in your surrounding, there are some radiations which are already included or which are already present in your atmosphere, right? So those radiations are known as background radiations because we are not finding the count rate of those radiations which are already present in the atmosphere or in your experiment. We are only specifically finding out the number of radiations of that element which is placed in front of the detector, right? So let's suppose
Yes,
if
sir.
include the background radiation. So the concept of background radiation is very simple. So if we talk about the background radiations, in the thermal physics, we studied about the radiations from the sun, right? So from the sun, we are already getting the radiation. So those radiations are already present in your surrounding. So those radiations are background radiations plus we are using electromagnetic devices. So they also emit different type of radiation. Those radiations are not, it is not compulsory that all the radiations are very harmful, right? But still those are radiations because they have very high frequency as compared to the visible light or any other region. So these radiations enter the earth atmosphere from space and are present everywhere. It is just like the concept of the air resistance because in the motion and forces chapter, we used to consider sometimes that air resistance is negligible. So we only suppose that concept, right? But we know that air resistance is always there every time in the experiment. But just for the time being, for the question, we consider that air resistance is negligible. So just same case with the background radiations because these are present everywhere. And the next point that it is not compulsory that these radiations are very harmful or they just always damage your surroundings. So it is not compulsory. but still they are able to count the readings from the detector.
So what about radiation from rocks?
Radiation,
From rocks.
yes. Basically, radiation in rocks are, these are the sources of radiations, right? Because sun and electromagnetic, because sun is also a natural source of radiation, right? Because electromagnetic are like the artificial one. If we are not using that electromagnetic devices or the radiations, so there will be no artificial radiation in the atmosphere. But if we talk about the natural sources of the background radiations, so rock, mineral, cosmic rays, underground radioactive sources, nuclear waste, these all are the sources of background radiations in the atmosphere.
Oh, okay.
Sir, I have a question.
Yes.
How is one supposed to remove radiation from a place?
Basically, for that purpose, you have to properly cover that place with the material, just like last time we discussed that gamma radiation is the most powerful because it contains the most penetration power as compared to alpha and beta. So that gamma can be stopped by the help of the lead material, right? So use the proper material that actually resist all the radiations coming from the surrounding. Okay, just like in the different documentaries and the video clips, you observe that they use proper the suit for that to just resist those radiations to enter into the body. Same goes with the atmosphere, that you have to use a different construction material to always resist the radiation coming from the surrounding. But it is not 100% possible to resist all the types of radiation, because still you are using the same electromagnetic devices. So you are already producing those electromagnetic radiations in your surrounding. But if you want to resist those radiations, so we have to use different materials that actually resist, just like the lead material or any other strong material than the lead, so that it stops you from the radiation.
Sir, is there any material that absorbs radiation?
Basically, if you take the example of the lead, so lead is a strong material, so lead will not reflect back the radiation, right? Actually, it absorbs the radiations, because we studied about the penetration power. So if you talk about the alpha particles, so alpha can be stopped by the paper, so it means that paper absorbs that radiation, right? Because radiation is coming out from the nucleus, and if you are using a paper or any other material, so that material is also made up from the atoms, and atom contains the nucleus, right? So that's why they are absorbing the radiation just like our body. Because if you take the example of the x-ray, so when x-rays pass our body, so basically that damage our cells and tissues, because we are absorbing that radiations. Okay,
Okay.
so this is the concept. And if we talk about the sources, so sources will be rocks, and minerals, cosmic rays, underground radioactive reserves,